Okay, so next session is fundamentals of deep learning, hands-on with image processing using CNN. The keynote speaker for this session is Sweeti Shah. Dr. Sweeti Shah is an assistant professor in Department of Computer Engineering at the National Institute of Technology, Kurukshetra, Haryana, India. Prior to her current role, she served as an assistant professor at IIIT Kottayam. Dr. Shah earned her master's degree in computer science and engineering from Babasaheb Bhimrao Ambedkar University, a central university located in Lucknow, UP. Dr. Shah received her Ph.D. from the Department of Computer Science and Engineering at the National Institute of Technology, Pondicherry. She is a recipient of AMTech Gold Medal and has qualified in GATE CSE and NET computer application. Her research interests focus on machine learning, deep learning, and bioinformatics. She has published in several reputed SCI index journals and international conferences. So over to you, ma'am.
Thank you so much, sir. So I'll just share my screen. My screen is visible to everybody?
Yes, ma'am.
Okay. Thank you so much. So let us just start with the session. And the topic is image processing using CNN. Okay, so before starting, let us have some conversation regarding what has happened past few days back. That means we are talking about image processing. Okay, so how our image processing plays a role in modern military tension. Okay, we have heard the news of India and Pakistan. Okay, some tensions were going on. So let us see how this image processing plays a role in the modern military tension. Okay, so you might have heard about the term surveillance. Okay, so drones and the satellite images uses this image processing technique to detect the enemy movements, vehicle types, or even weapon installation. Okay, and we have the real time processing also, which helps to distinguish between the military activity and the civilian activity. So how this image processing is playing a major role in the current day to day life. Okay, next we have seen uh, our military peoples monitoring the borders. Okay, so how they are monitoring it? They are monitoring with the helps of cameras with night vision and thermal image processing. They will have the live footage to detect the intrusion or the unusual activity, and there will be some algorithms which will be going on behind these. Okay, next we have the facial recognition and the target identification, so which is used in the counter terrorism to track and verify the suspect from the captured images or the video. So see how image processing is playing role in our current day to day life. In terms of surveillance we can say, okay, in terms of monitoring the borders we can say, in terms of recognizing the facial of a person in order to identify the target also, everywhere we see that image processing is playing a major role. Okay, and we have also heard about some news uh, we have a good air defense mechanism which we call it as S400. Okay, so we are able to sleep at night just because of this mechanism only. Okay, and we are sleeping, Pakistan is sending missile drones. Okay, just because of S400 we are able to sleep at night. How means how this S400 is processing the data? The question is how it is getting like fixing uh, it is getting launched at the same time when this day Pakistan is sending the drone missile. Okay, now the concept is little bit relevant to the image processing principle only. So I'll just have the discussion first little bit about all these things, because as a academician we will be having little bit inquisitive of the feeling that how this is happening, let us have some glance about all these things. Then we'll go into in-depth knowledge about image processing using CNN, also some other models we'll see.
Excuse me.
Okay. Yes, yes sir.
Ma'am, only first slide is shown, ma'am. Can
Yes sir,
you?
yes
Oh,
sir, I
yes,
have
ma'am.
not moved.
Yes, it's moving. Moving, moving. Okay.
Yeah, yes, yes sir. Okay, so so let us just see. Actually, this is not present in the slide. I'm just sharing my feelings, okay, that how this S400 is processing the data, because it is a little bit relevant to the image processing principle. Okay, so first it is like we have this step. First is radar imaging and the signal processing. Then what are the various steps we should know? That is radar imaging and signal processing, where S400 will use the high frequency radar system, okay, to see the airspace. Okay, so these radars will generate the 2D and the 3D electronic map of the battlefield, which is similar in concept to how an image is formed. Okay, and then the signal reflections from the aircraft, drones, or the missiles are processed to extract the features like speed, altitude, trajectory. So first, what I told was the first step for S400 was radar imaging and signal processing. I'm just telling you, which is not present in the slide. I'm just sharing my opinion about what has happened in the past few days, right? We'll start in depth about this topic, image processing using CNN. Okay, the next step, what I felt like, I read somewhere that the next step after radar imaging and signal processing was target classification. So it is trying to classify the target and then it will evaluate the threat. That means it is similar to object detection in image processing. That means the S400 will identify whether a detected object is a civilian aircraft, cruise missile, or anything else, right? That means it will use the pattern recognition mechanism based on this radar signatures. Okay, then after that trajectory predictions will happen and missile will be guided. Okay, so we see that our modern technology is also using this image processing techniques. Okay, so now let us see in from scratch. I'll be telling you that what is an image, what is an image processing, what are the various types of image processing, what are the various applications associated with it, how does the model look like, how can we can create a CNN model, what are the other pre-trained models which are similar to it. Okay, followed by the conclusion. So let us understand what is deep learning, machine learning, artificial intelligence. Maybe in your previous lectures or in your previous session you might have had the glance of all these things, but again I'll tell you so that you people can connect the dots. Okay, again. Okay, so here in the example, here in this figure we see that artificial intelligence is a broad field which is focused on creating machines that can perform tasks which require human like intelligence. Like suppose decision making is there, reasoning is there, and machine learning here in the figure we see is a subset of artificial intelligence which involves creating algorithms that allow computer to learn from the data and improve over time without being explicitly programmed for a specific task. That means we are like we improve over time without being explicitly programmed. Okay, now deep learning here we see that is a further subset of machine learning which utilizes the deep neural network with many layers to learn from large data set. Okay, and so it we can say that deep learning here we see this is a subset of machine learning. It will excel at complex tasks like image recognition. We have the NLP task, natural language processing is there. So we can say that ML is a technique within AI that learns from the data, and DL is advanced method within ML using deep learning models for high level automated learning. Okay, now if we see this deep learning, we have already seen is one of the branches of artificial intelligence that has seen exponential growth in the recent years. Okay, so this deep learning has basically transformed the field of image processing by enabling the machines to automatically learn complex patterns and features from the raw image data. So previously we were having some traditional image processing techniques which will rely on manual engineering features, but this deep learning use specifically for image classification, we have the convolutional neural network that will allow the end to end learning, where the models can identify edges, textures, your shapes, or even the abstract features directly from the images. So this automation will lead to significantly higher accuracy in tasks. The task can be your image classification, your object detection, your segmentation. Either you want to enhance the image, there can be various models. Okay, the we'll see in the later slides that what is VGG, what is ResNet, what is EfficientNet, which are commonly used for the classification purpose. And you might have heard about some models like YOLO, faster RCNN, that is only for that is preferred actually for the real time object detection. Okay, and we have other popular models also, UN, mask, RCNN, that are popular for pixel level segmentation. And similarly we have a model, GAN, which is called as the generative adversarial network, which is used for image generation. So deep learning models are trained on basically large image data set using frameworks like TensorFlow or PyTorch, and are capable of generalizing. Okay, so this makes them particularly valuable in various domains. This can be applied in medical sector, okay, agriculture, security. Okay, and if we talk about this image, whether our image is a structured data or unstructured data, okay, if we look into it, the structured data can be your phone number, okay, customer name and product name, that means whatever is present in the CSV file here. Organized data, whatever, if the data is organized, that is called as the structured data. And if the data is not organized, it is called as unstructured data. That can be your faces, your pictures, your images can be your unstructured data, your audio file, your video file. Okay, now before going in depth about this convolutional neural network, we should have the knowledge that what is this supervised learning and what is this unsupervised learning. Okay, so supervised learning and unsupervised learning are basically two types of machine learning techniques, we can say, that differ in the nature of data we use. So supervised learning will involve training a model on labeled data. Here you can see in the figure that we have the images of the cat, and these images have some name associated with it. Okay, so this name is basically the label which is associated with the image. Okay, and if this name is not present, this label is not present to it, that means that is unsupervised learning. Okay, so we are going to give this data, we are going to provide this data to the machine learning algorithm, and seeing the model to classify, to categorize the data. Okay, so the goal is to learn a mapping from input to output so that the model can accurately predict the output for new unseen data. And this approach is widely used in tasks such as image classification. We can have spam detection, price prediction, where the outcomes are clearly defined. Common algorithms in supervised learnings are logistic regression, decision trees, support vector machines, and neural networks like CNN. Okay, so if we talk about unsupervised learning, in contrast to it, it deals with unlabeled data where the labels are not present to it. As I already told in the previous diagrams, labels were present. Here, labels are not present. So the model tries to uncover this hidden pattern, groupings, or structures without prior knowledge of the output. So it is used in scenarios like anomaly detection, data compression, and the techniques which are used for all of these are like k-means clustering, we have hierarchical clustering, we have PCA, which is called as principal component analysis, which are commonly applied in unsupervised learning. Okay, now we have seen as of now what is an what is supervised, unsupervised learning, what is MLDL, and what is artificial intelligence. Now let us see what is an image. Okay, so an image is a visual representation of an object, scene, or any abstract concept. Okay, which we capture it in a digital form, or we create in the digital for displaying, processing, or analysis purpose. An image is basically made up of grid of small units, which we call it as pixel, where each pixel will contain a color or intensity information. The arrangement and value of these pixels will determine the overall appearance of the image. And the image can be your grayscale image, where each pixel represent a shade between the black and the white. Or color also we can have. Commonly these colors can be the RGB, that means red, green, blue, which we call it as RGB. Okay, so the resolution of the image is defined by its width and height in pixel. Here we can see that we have defined it with width and height. Okay, and the amount of color detail is determined by the bit depth. Okay, it can be 8-bit, it can be 24-bit. So the images are stored in various formats also. We can have PNG, JPG, JPEG, BMP with different compression and quality characteristics. So in fields like computer vision and digital image processing, images can be served as the data for analysis purpose, classification purpose, detection purpose, your enhancement purpose, and using these algorithms we can do. Okay, what we have discussed in the previous slides. Okay, now let us see what are the types of images. First, we have seen that we have a binary type, we have a grayscale type, we have the color, which we call it as RGB, we have multispectral. Apart from all these four, there are several other types also. Let me tell you one by one. Okay, grayscale image will contain shades of gray, that means representing the intensity level of light. Okay, that will vary from 0 to 255. Then we have binary image will consist of only black and white pixels. Either it can be 0, either it can be 1. Okay, then we have the color images. Color images typically is a RGB color model, which represents a full range of colors and are widely used in tasks like object recognition. Okay, then we have multispectral, that captures basically data across multiple wavelengths beyond visible light. Okay, which is useful in remote sensing, I can say. And apart from these four types, we have other categories also. Like suppose we have indexed images. Indexed images uses a color palette. Okay, here you can see an image of a parrot, where you can see the color palette for more efficient memory storage. We can see different shades of the similar color. Okay, there is little variation. Okay, light, some little bit, some lighter orange, darker orange. Okay, and then we have the apart from this binary grayscale RGB indexed, we also have HDR images, which captures a broader range of light intensities for being detailed in high contrast scenes. Okay, and we also have infrared images to detect the heat signatures for applications like night vision. And we also have depth images, where it represents the 3D information, often using 3D reconstruction and autonomous driving. And we also have panoramic image texture images as well. So basic, if I talk about, we widely we will see is binary, grayscale, RGB, and multispectral, and even indexed also. Okay, now let us see what is image classification. So based on the pixel in an image, it can be classified into four major types with different composition of color. Okay, so the image classification, we can say it as a fundamental task, okay, in computer vision and deep learning, where the ultimate goal is to assign a labels or category to an input image based on its visual content. For example, model might classify an image as a cat, dog, or car, depending on what it sees. So this process involves analyzing the patterns, textures, shapes within the image to identify and distinguish features that correspond to specific classes. Okay, so in image classification, we see that the data set of labeled images is used to train a model using CNN, which learns or map the image feature and labels. During the training, the model will adjust its internal parameters to minimize the differences between its prediction and the actual labels. And once the model can be used to classify new unseen images. Okay, uh, then we'll see the it will get good accuracy or not. Okay, Then if we see the common applications of image classifications, we might be familiar of facial recognition, medical diagnosis. In medical diagnosis, we have seen that we can identify the tumors in the x-rays. We can even use in the agricultural field, that means plant disease detection. As I have joined 10 minutes before, I saw that sir was I think explaining about the plant disease detection only, where I saw that he was using mobile net, which is also a transfer learning model. Okay, so we'll be discussing about this transfer learning model in the later slides. Okay, so uh, so binary image, as I have already discussed with you in the previous slide, how does the binary image look like, where we can see that the shades of black and white. Then we have the grayscale image. As we can see, we have different shades here, which varies from 0 to 255. Then we have the RGB, which is a combination of red, green, blue. Okay, then we have the indexed image. We can see the color palette over here. Now let us see what is image processing. We have seen what is image. Next we have seen how we can classify the image, and next is what is image processing. Okay, so image processing is a core of computer vision. So basically it is a method which is used to perform operations on image to enhance them, right, and extract useful information or prepare them for further analysis. So it involves various techniques that manipulate pixel data of digital images to improve their quality. We can detect the patterns or make them suitable for tasks such as recognition or classification. So this image processing can be broadly classified into two types. First is the analog, which is the traditional image processing technique, and second is the digital image processing, which is the nowadays what we are using it. Okay, so what is this analog image processing, which is basically, in our previous time we will be seeing that whenever we have some birthday parties or we have to go for any trip, we'll be having the camera, and okay, we'll take the photographs and then we'll take out the print out of it, like the hard copies. There is no digital thing, all hard copies are present. In the previous time what we used to have, that type of. Okay, now is digital image processing, which involves computer algorithms to enhance or reconstruct an image. Okay, so we can say that in digital image processing, an image is basically represented as a matrix of pixel values, and various mathematical and computational techniques are applied to transform or analyze it. So the common image processing operations basically include noise removal. uh, if you have some image which is noisy, some it's blurry, we try to deblur it, we try to remove the noise from it, we try to enhance the contrast so that the image looks more beautiful. Okay, and for edge detection purpose also, image segmentation, filtering. Okay, there are some morphological operations as well. So these techniques are widely used in the field, such as medical imaging, remote sensing, your industrial inspection, your surveillance, and even your robotics as well. So with the integration of artificial intelligence, particularly I'm talking about the deep learning. Okay, so image processing has advanced significantly, and this deep learning model, which is a convolutional neural network, automatically learn features from raw images and perform complex tasks such as image classification, object detection, your semantic segmentation more accurately than your traditional methods. Thus this image processing plays a very crucial role, I can say, in various modern application that rely on visual data understanding and analysis. Okay, so if we see the different phases of image processing, we have image acquisition, image enhancement, color image processing, wavelet processing, multiple solution image restoration, image compression, decompression. Okay, so what is this image acquisition? Obviously this is the initial digital phase where uh, This digital image detection is used in creating a specific image such as real life situation or the internal arrangement of an object. So this term is widely used to describe picture processing, storage, display and printing. That means this is the initial step. You are trying to you are using it to create a specific image, right? After image equation, what is the next step? We have image enhancement. Okay, we are trying to enhance the image. How we are enhancing? We are deblurring it, we are making it more proper, we are making it more suitable, beautiful, I can say. Okay, you're going to remove the noise here, right? Next we have color image processing. Okay, human color is used to classify products, building materials, food locations and time of day. Color is utilized in the image processing for separation. Okay, next is your wavelet processing and multiple solution. So this wavelet are similar to the different types of paint brush used for minor detailing with respect to the topographies in a painting. So it is one of the effective tools for representing the image. So these wavelets will allow the extraction of multiple solution of the same image. Then we have the image restoration, which is nearly similar to the image enhancement only, because here again we are trying to enhance the quality of an image primarily by removing any potential corruption or for a better version. This method is based on probabilistic and mathematical model, and it can be used to remove the blur, camera misfocus, noise, watermark, missing pixels and other errors that can hinder neural network training. Okay, then we have the image compression and decompression. So here we are trying to compress the image. What is compression? That means we are trying to reduce the dimension or the resolution or the image, or we are trying to decompress it. That means trying to restore the image to the original dimension and resolution. Okay, so I think as if now everybody will be clear what is machine learning, what is deep learning, what is mm, artificial intelligence, what is image, how do we classify the image, what is image processing. Okay, and what are the different types of images. So we have next is categories of image processing. So the main purpose of image processing will fall under five different categories. First is visualization, represent processed data in a comprehensible manner, for example by giving visual form to objects that are not visible. Okay, so first is you are trying to give some visual form to the object that are not visible. Okay, second is image sharpening and restoration. So the main purpose of this thing is to enhance the quality of the original image. Next is image retrieval, will help in searching for similar images from a large database. Next is object measurement, which is used to measure the various objects in an image. Next is pattern recognition, which is used to identify the pattern of different objects present in an image. Okay, so let us see some popular image processing tools. Okay, so first is OpenCV. You might have heard about OpenCV, Keras, TensorFlow, all these things. So OpenCV is one of the widely used or simple to use libraries in image processing. The multi platform tools helps in editing photographs, your videos with the programming language in C++ and Python. Okay, and this is open source, which helps in building a common infrastructure of your computer vision and accelerates the use of machine in a commercial goods. Okay, first is OpenCV, second we have is TensorFlow, which is well known machine learning and deep learning library. In recent time many of us are using TensorFlow only. So due to its simplicity of API, it becomes popular and outperform other libraries, and it is used in machine learning applications like neural network. In our code also today what we are going to discuss, we have used TensorFlow only. So I'll just show you that before writing a piece of a code for CNN, we have to import this necessary libraries. If you are not importing, our model will not work. Okay, so this library we have to import it and then we will work on it. Okay, Then we have MATLAB also. So if you want to write a code in MATLAB, you can write a code in MATLAB. If you want to write a code in Python, you can use Anaconda, you can use Jupyter Notebook, you can use PyTorch, you can use a Spider. Okay, these are the platform where you can write a code. And we have separate, we have MATLAB. So MATLAB, still people are using MATLAB. So um in MATLAB the code is very concise in comparison with C++, and this results in easy utility and troubleshooting as well. And uh, you can you have we have a separate software for this. Okay, like we have the for the Jupyter, Anaconda is there now. Now next is Pillow. What is this Pill? The full form of this PIL is Python Image Library, which support a wide range of image formats. Specifically it is for images. Okay, and it accepts the image in the various formats, that is JPEG, PNG, GIF, BMP, TIFF, PPM. So it allows us to perform rotating, resizing, grayscaling, cropping of the original image, and we can use it in our Windows, Linux, Mac. Okay, next is Keras. Keras will learn on the top of the TensorFlow, I can say. And Keras is a collective library of image processing that includes data from different libraries like TensorFlow, Thanos. And since scikit-learn and PyTorch come under TensorFlow, so it can also get placed in the Keras libraries. So let us see the various applications of image processing. If you are if you are happy with this, and if you are very inquisitive of the work, like how this image processing is working, so let us see some applications. And if you feel very inquisitive, you can go to the Google Scholar, search some applications which I am discussing right now, and you can read the papers in the Google Scholar and refer to it, and you see how they have implemented. Let us see some applications which you can carry out in your research work as well. And you can see the Google Scholar also. Okay, let us see some applications which can be carried out in your research work. So first is your computer machine vision. So what is this all about? So this is one of the interesting application of the digital image processing, where computer vision will see, identify things and process the whole environment by delivering insights from its observation. This is used in self-driving cars, drones, and other technologies. You might have heard about Elon Musk Tesla cars. Have you must have read or seen in YouTube channels that he has made a self-driving car, where you just have to sit, the car will take you from source to the destination automatically. Okay, so Tesla is a good example of the self-driving cars. We have the drone and other technology. Drones, I can already tell you that the war which has happened between India and Pakistan, you can see the drone technology. Okay, now where the detection of image is necessary for the automation, here in this image you can see that we have a road, we have car, we have a pole, building, plants. Okay, so our algorithm will detect the object, whether this is a person, whether this is a car, where this is a pole, building, where this is a tree. Okay, how precisely it is detecting, it depends on the algorithm, how you have written the algorithm. Okay, now this, if you want, you can search it in the Google Scholar. Like if you want to detect something, if something else apart from this road one. Okay, maybe you can detect some potholes in the road. On the road we have some potholes while driving. You can detect that in disaster, flood. When some flood has happened, you can detect flood prone areas, how you can save person. Okay, you can carry out this research work. Now next we can see here filter editing apps and social media. Almost all the social media channels and editing apps provide these filters for images. Okay, you might have heard about this Ghibli trend in chat GPT. Like there was some trend going on, everybody was posting in their WhatsApp, everybody was posting in the Twitter, LinkedIn also. Even I have seen that you just have to give your image to the GPT, and you just have to give the prompt that convert the image in the Ghibli art. So it will automatically convert the image into Ghibli trend. Okay, So this is all another type of, I can say, an application where you are giving a image input to the model. Okay, the gpt in if you're giving the image to the gpt, behind this some algorithm is working, that is converting an image to some other format. Okay, so our input image is getting converted into the ghibli image. Okay, and this, if we apply some if we have seen that while talking also some filters will get enabled. Okay, the Google Meet also, when we have entered Google Meet, some filters will be there which will change your background, which will enhance the beauty of your face. Okay, some sorts of filters will be available. Okay, additionally the default camera of the mobile also provide your filters for taking pictures nowadays, and these filters are widely used applications of image processing. So everywhere you see image processing is playing a major role. You have the mobile phone, you have laptop, you have your tablet. Everywhere you can see technology is using image processing very much. Okay, so filters are the basically set of functions which is used to add more colors and other aspects to the existing original pictures to make it more appealing, right? Now in terms of medical image retrieval, so 2019, I think so, COVID, we have seen how many, like the exponential growth in the number of cases we have seen for the COVID cases. Okay, so image processing is playing role there also. Okay, so in terms of radiography pathology, we see this deep learning algorithms analyze these medical images. Like suppose a person is having COVID or not, if we have the chest x-ray image of a person, we can use the image processing technique, we can classify whether the person is having COVID or not. Okay, so in terms of medical image also, this image processing is playing a major role. Okay, so I'm giving you various applications. Now it's up to you which you are interested. You can pursue related applications related to medical or agriculture or your social media or this computer vision. Okay, so image processing in the in the field of medicine has played a vital role in well-being of humankind. Okay, it has drastically increased the diagnostic process. And in radiology we see that deep learning algorithms can analyze medical images such as your x-ray, ct scan, mris to detect the abnormalities, tumors, fractures and other conditions. They can also assist radiologists in making more accurate diagnosis. Okay, so you can use the normal image, you can use the radiography image. Radiography images are just means the x-ray images that looks black and white transparent type. Okay, so next is pathology. So deep learning models can aid pathologists in identifying cancerous cells or tissues in histopathology slides, improving the accuracy and the speed of cancer diagnosis, right? Now we can see image reconstruction. Okay, now this is possible now that we can reconstruct the image. The image is torn off completely, but now our AI is generating the image and filling the gaps very perfectly that you cannot even identify that this image was torn off. Okay, how beautiful it is trying to reconstruct it. So the reconstruction of old and damaged photographs can be rebuilt with the help of image processing only. Okay, so this function takes up the existing data set of the photographs and then recreates the missing part of the object in the photograph. So further it can be used to edit photographs by detecting the edges, sharpening, retrieval, blurring, conversion and recognizing objects in the image. Okay, next we have the traffic sensing technology. Okay, previously what we have seen was the example where we are detecting the object, where we are detecting whether it is a car, plant or a pole, human being. But now this domain is this application is we are trying to detect the traffic. Okay, we are sensing the traffic. Okay, so it will use the video image processing system. So this is usually set up in multiple lane roadways. The system shows a signal off and on whenever a vehicle enters and exit the detection zone. Okay, so this function involves image capturing, image processing, and telecommunication system to produce the expected output. So this is also helps in reading and license plates of the vehicle while making process data of the vehicle model, monitoring the speed and much more. So you have not only this traffic sensing technology, we also have the like whenever you are passing the toll, your number plates will be recognized automatically. Okay, and then your toll will be deducted and then you can take your car. Okay, next we can also have this application that whenever you are crossing the limits, uh, on the top of the board, that challan will be deducted. If you are crossing 100, then challan will automatically will come to you. Okay, so you don't police don't have to stand there, it is automatically detecting. So all this is image processing only. Okay, next is pattern recognition, face detection. These are other various applications which we can see. So these are all the research areas. These are all the research areas. Wherever you are comfortable, wherever you are feeling that this topic I am very interested, I want to pursue this topic, please go to the Google Scholar, search the respective topic in more in depth, so that you will get currently what is happening, what type of model they are using, right? So next is pattern recognition. Image processing is often combined with artificial intelligence. So we'll see the difference. What is computer vision? What is pattern recognition? What is digital image processing? We'll see in the later slide what is the difference between all of them. Okay, so the pattern recognition often assists in handwriting analysis, computer aided medical diagnosis, image recognition, and the function detects the pattern of objects and other aspects in an image. Next is the face detection. Face detection, that means you're detecting the face of a person, mostly the eyes, the edges, including the distance between the eyes and the shape of the face, etc. And the function is used in entertainment industries to detect the face in the motion, and in smartphones to secure the personal details. Okay, now let us see what is the difference between artificial intelligence, computer graphics, computer vision, digital image processing. So this might look very similar if I say that all are related to image only, right? So what is the difference? So with the help of this diagram, I think everything will be very clear right now. Okay, an image input can give an input can give an output of either same image or description. Just see, input image input can give an output of same image or a description. When the output is description, it is called as computer vision. Okay, so here, okay, computer vision. So here you can see that input image you are giving, output description you are getting, that is computer vision. Okay, now what is computer graphics? If an input description gives an output of an image, it is known as computer graphics. Computer graphic input description is the input, and output is output is your image. Okay, this is computer graphics. Its application widely recognized in the in entertainment industry. Okay, now let's see what is digital image processing. This can be spotted in self-driving cars, your MRI scans, your parking occupancy detections, and others. If the output was also an image, that means input is image, output is image, that is digital image processing. Okay, now what is artificial intelligence? Okay, if the same description input gives the output of the description, input also description, output also description, that means artificial intelligence. Now I think you will be able to distinguish between the computer vision, computer graphics, artificial intelligence, and digital image processing, because only minor differences are there. You might get confused also. Okay, now let us see what is image processing using CNN. Okay, so first is it involves using CNN architecture to perform various tasks. So let us see what is CNN. Okay, CNNs are basically specialized type of deep learning model that is designed to process and analyze the visual data, like your images or the videos, because we have frames are images only. Okay, CNNs are particularly powerful because they can automatically learn the features and and from that means features from simple edges and textures to complex shapes directly from the raw pixel data without the need of manual feature engineering, we can say. So that is only the difference between machine and deep learning. That means you don't have to extract the features manually. In deep learning, features will be extracted automatically. Okay, so this deep learning has several layers which we'll be discussing in the later slide. So let us just see the like what type of task that can be performed by the CNN. First is the image classification. That means you can identify whether like animal is a cat or a dog. Then we can detect the object, that means locating the faces in an image segmentation, that means marking each pixel as a part of specific object. Then we have image enhancement, that means denoising, super resolution. Image generation, that means we can have deep fake creation, style transfer. So all these are the applications only, I can say. Okay, now how CNN work in image processing. So we have several layers. So we have, first is a convolutional layer. So these apply filters. So convolutional layer will basically detect the features like edges, textures and patterns. So how they are, because the convolutional layers, in convolutional layers we'll see in the visual format. Okay, we'll see in the visual format, that would be more clear to you. And next is the activation function. The most commonly activation function which is widely used is ReLU, that is rectified linear unit. Why it is used? To bring the non-linearity. Okay, and which allows the networks to learn from more complex patterns. Next, we have the pooling, and basically, this pooling will reduce the spatial size and will retain important features. That means these will reduce the height and the width of the feature map, and making the network more efficient and robust to slight translation or distortion in the image. Next, we have the fully connected layer. So these come at the end of the network and are used to perform the final classification based on the feature extracted by the convolutional and pooling layer. Next, we have the softmax sigmoid layer. This basically will provide the probability distribution for classification task. So what are the various CNN architectures? We have several CNN architectures, that is LeNet 5, LXNet, VGGNet, ResNet, UNet, YOLO. So we'll see in the code as well in the more depth form. Okay, applications we have already seen. Okay, now let us see convolutional. So if I say that you have to categorize, you have to classify the handwritten digit using convolutional neural network, and here you can see a digit 2 which has a height, width, and this one is RGB. Okay, height is 28, width is 28, that means 28 cross 28 into 1. 1 is basically your RGB. Okay, now when you are performing your convolutional neural network operations, first is see how the model, how it is going to classify. We have several layers over here. First is convolutional layer, max pooling layer. Then this is the second convolutional layer, second max pooling layer, fully connected layers. Okay, so let us see what is this, what is happening. First of all, this is your input image. Like suppose here I have written 28 cross 28 size. Let's take an example, this is 32 cross 32. So the pixel representation of this two will look like this, which we can see here. Some numbers are placed inside, and this is the two. And now what is this pixel representation? We are going to perform uh, Hadamard multiplication operation. Okay, so we have to take a kernel of, like suppose we have taken 3 cross 3 kernel matrix. We are going to perform the multiplication operation over it, and then we are going to write it in the resultant matrix, which we call it as a convoluted matrix or the feature map. Okay, now application of the convolutional task using the stride of 1 with 3 cross 3 kernel. What is this stride? When you are moving the pixel with value 1, that means stride will be 1. When you are moving the pixel with a value 2, the stride will be 2. That means you are putting the matrix over here and then multiplying, then next you are keeping multiplying and putting the resultant value over the convoluted matrix. Okay, so let us see, let's not confuse what is this convolution. So the purpose of convolution is to extract the features of the object on the image locally. That means the network will learn specific patterns within the picture and will be able to recognize it everywhere in the picture. Okay, so you can see here we have the input image, we have the filter, we have taken the filter 3 cross 3, and the resultant is the feature map or the convoluted matrix, we can say. So this matrix is going to get multiplied with this. Okay, see how this is sliding and how this is putting the result in the convoluted feature or the output matrix. You can see how this is getting multiplied, it is sliding one by one. That means stride is 1, and the resultant value is kept in the output matrix. This is the input image matrix, this is the kernel matrix 3 cross 3. This is performing bitwise multiplication operation, which we called as a hadamard operation, and then we are getting the feature map, which we call it as output matrix or the convoluted matrix. Okay, once this is done, when the convolution operation is done, this is the mathematics behind this CNN model. Okay, because while writing the code we are not able to see these things, what is happening behind. Okay, so now let us see the application of max pooling with a stride of 2. When you are writing the stride of 2, that means you are moving the pixel value by 2. Okay, that means you are putting that kernel 3 cross 3 kernel matrix, you are sliding it by 2. Okay, so we see that what is pooling. Pooling is basically a very crucial, I can say, operation in CNN that serves to reduce the spatial dimension, that means the height and the width of the feature map, while retaining the most important information. This is basically, we call it as downsampling process. Okay, so this downsampling process not only decreases the number of computations and parameters in the network, but also helps to prevent the overfitting. So we'll see in the later slide also what is this overfitting, and will improve the model robustness to variations like translation or distortion in the input image. The most common type of pooling we use is max pooling only, which select the maximum value from each patch of the feature map. Okay, if we are talking about the average pooling, that means it computes the average of the values in each region. Okay, if we are talking about the min pooling, that means we are taking the minimum value. Okay, and there is also called as global pooling is also there, mean square also pooling is there. Okay, so there are different varieties of pooling operations which can be applied after the convolutional layer. For example, let's take an example, like suppose you have 2 cross 2 max pooling operation. The feature map is divided into non overlapping 2 cross 2 blocks, and only the highest value from each block is retained. This not only simplifies the representation but also emphasizes the most salient features, contributing to more efficient and effective learning in image processing task. Okay, so next we have the non-linearity, which is ReLU. At the end of the convolutional operation, the output is subject to an activation function to allow the non-linearity. This usual activation function for CNN is ReLU. So all the pixels with the negative value will be replaced by 0. Okay, next we have the fully connected layer. We connect all the neurons from the previous layer to the next layer here, because we are saying it is fully connected. So we are connecting all the neurons from the previous layer, and we use the softmax activation function to classify the number on the input image. So when I was telling something in the middle, we have come across some terms like overfitting or underfitting. So I would like to make you aware with few terminologies, like what is this overfitting and underfitting. So overfitting and underfittings are basically two common challenges, I can say, in training machine learning models, uh, including our CNN also. Okay, so overfitting occurs when a model becomes too complex and learning not only the underlying patterns in the training data, but also the noise and the irrelevant details as well. Okay, so as a result, while the model perform excellently on the training data, it struggles to generalize to new unseen data, leading to poor performance on the test set. So on the other hand, underfitting will happen when the model is too simple. failing to capture the underlying pattern in the data, and which results in poor performance on both training and testing sets. To address these issues, okay, to address these issues, regularization techniques are employed. Okay, so what is this regularization techniques? Regularization methods are like dropout, we have L2 regularization, that means weight decay. We have early stopping, which will help to prevent the overfitting by reducing the model complexity or preventing it from fitting noise in the data. Okay, so dropout, for example, randomly disable a fraction of neurons during training, forcing the network to learn more robust and generalized representation. And now we have L1 and L2 regularization, normalization, okay, which adds penalty term to the loss function, encouraging smaller weights and thus preventing over complexity. And early stopping monitor validates validation loss and halts training when the model starts to fit. Okay, and we have the data augmentation also, is another technique, we can say, that artificially expands the training data sets by applying random transformation to images, which improves the model ability to generalize. Furthermore, we have batch normalization as well, which stabilizes the training and improve convergence by normalizing layer output, helping to reduce overfitting. So, balancing this overfitting and underfitting requires careful applications of these techniques, ensuring the model is complex enough to learn meaningful pattern, but not so complex that it overfits to the training data. Okay, so we have discussed all these things right now. Okay, so let us see how the image can be classified. Image can be classified using CNN. Next, we'll see about the cat and dog image. Okay, so I told you that some common libraries, I have told you that you TensorFlow, Keras, okay, OpenCV and all those things. So in right now I'm trying to classify the data which is cat and dog images. Okay, I'm trying to classify dog and the cat image. Okay, so the data set contains 25,000 images of cat and dog. So we, before starting, we need to import the necessary libraries like pandas, TensorFlow, NumPy, Matplot for visualization purpose. Okay, now now we see that image height and width. So and batch size is 64. What is the image size and width? Which is 128 cross 128 into 1. If we say 1, that is RGB. Okay, so what we are going to do, we are going to load our data to our data frame, and we will see the path of the images over here. Okay, now load each image and resize it to desired shape. Whatever size you want to resize, you just resize it to the desired shape and convert each data and labels to tensor. Okay, now what we are going to do, we are trying to normalize the data, and then what we are going to do is we just check the images, how does it look like. Okay, so we have different images of the cat and the dog over here. Okay, see, this is the sample data. So as I already told you, this CNN model will have several steps like convolutional operation, pooling operation, several layers. So, okay, let us focus on the model right now first. Okay, so we can see here that we are going to create our model. We will define our model, my CNN model, and we will see model equal to tf.keras.model.sequential. Now we are starting our model. After writing this, we will add several layers to it. So we have added layer convolutional operation. Convolutional layer we have added over here 8 neurons, and what is the size? 3 cross 3. This is the kernel size 3 cross 3. We are going to, what we have seen in the image, that the matrix will be overlapping and Hadamard operation or the multiplication operation was performing now. So this is the neuron, this is the filter size, and padding is same. Activation function is used is ReLU. What is the input shape? Image width, image height, and 3 is the RGB over here. Okay, after this convolutional layer operation, we have done the max pooling over here. That means it will take the maximum value of it. Okay, whatever matrix it is creating, the it is doing down sampling. Okay, what is the filter size? 2 cross 2. Next, again we are going to add one convolutional layer, we are going to add one max pooling layer. After that, again convolutional max pooling layer. So we can see here four convolutional and four max pooling layers have been added, and then we are going to convert into 1D array, that is we are going to flatten it, and then we are going to add an activation function which is ReLU. 512 is basically the number of neurons, and then in the output layer we have used sigmoid because we want whether the output is cat or a dog. You can also see the summary of your model over here. Okay, see, you can see the summary: convolutional layer, max pooling, convolutional max pooling, convolutional max pooling. Likewise, we can see there are several layers: flattening, dense layer, there are two dense layers over it. Okay, after creating the model, what is the step which we have to perform next? See, if I will run it, is going to take so much of time, so I am not running this code because time will be wasted in running the code itself only. Okay, so what we are going to run our model for epochs 20. That means entire data will be passed for 20 epochs, we can see here, and we can see the accuracy. What is the accuracy we are getting here? Okay, we are getting accuracy 93% accuracy we are getting over here, and the loss is, okay, sorry, accuracy we are getting over here, validation loss and the validation accuracy. Okay, and now we can see here that okay, we can see here the model accuracy and the model loss. This blue color is the training data, orange color is the validation, this is the predicted value. And so we can see the accuracy, the difference between these two lines should be minimum, then the results is very good. If the difference between these two is maximum, that means there is a lot of difference, the accuracy is not good or the loss is not good. See, we are not we are having 99% accuracy and 28% validation loss, we can see here. Okay, now we can see here our data, whether our data is overfitting. I have also talked about some terminologies, dropout, regularization, expand the data set, that means augmentation part. Okay, so what we have to do here is okay, this is, we have created the confusion matrix. Okay, now is to see how much accuracy we are getting over here. We can see the accuracy is very poor, so we need to augment the data over here. So we are augmenting the data, that means we are trying to expand our data set because we have less data set, or we are having overfitting, okay, or underfitting. Okay, so we are trying to rotate the image, see in various angles this image is going to get rotated, zoom augmentation, and we have done pull together. That means we are trying all possibilities to expand our data set. And uh, then what we are doing is, after augmentation, then we are seeing what is the accuracy we are getting and what is the loss we are getting. Now the accuracy and loss is decreased and accuracy is improved. Okay, so what our major step is, whenever you are creating a model, okay, whenever you are creating the model, if you are not getting accuracy, you have to fine tune your model. Okay, like suppose the loss I have used over here is binary cross entropy, or and see learning rate I have used, what learning rate, what optimizer I have used. You have to fine tune your model. If you are not getting, even if you're fine tuning, you're not getting, you check whether there is some problem with the data, you want to augment the data, you want to use L1 L2 regularizer, what dropout value you want. So you have to fine tune your models with certain parameters. Okay, now if we see, hmm, okay, so now let us see some pre-trained models. Okay, now let us see some pre-trained models. What are the pre-trained models? So right now we have seen that how we can create the convolutional neural network, how we can avoid overfitting, underfitting, how we can like fine tune the model. Okay, Now, pre-trained models, so the pre-trained this architectures are basically deep learning models only, that have been trained on large data sets such as your image net, and can be reused for various tasks without the need for starting the training process from scratch. So these models have learned to extract the useful features from images, making them highly efficient for tasks like image classification, object detection, segmentation. And some of the well-known pre-trained CNN architectures are LeNet 5. So one of the earliest CNN design for handwritten recognition we have. Okay, AlexNet is there, which has we can say this has revolutionized this deep learning with its 8-layer design and powerful performance on the ImageNet competition. Okay, next we have the VGGNet, which is known for its simplicity and deep architecture with uniform 3x3 convolutional. So we'll be seeing in the later slides what are all these things. Okay. Okay, and as I told you about the LeNet, AlexNet, VGGNet, we also have the GoogleNet also. Okay, we have ResNet also, Inception, DenseNet, MobileNet, Exception, EfficientNet. There are several pre-trained models. So let us see what is transfer learning. Basically, these pre-trained models, we can call it as a transfer learning models only. So the transfer learning model is a machine learning technique, deep learning technique, where a model train on one task, and that one task is reused or adapted to perform different but related task, I can say. So the core idea is to incorporate the knowledge acquired by the model from a large general data set and apply it to the more specific task or the domain with limited data. So this approach is particularly useful in deep learning, where training complex models from scratch can be computationally expensive and time consuming. So if I talk about in context to the CNN, transfer learning typically involves taking a pre-trained model such as one one like once trained on a larger data set like ImageNet, and fine tune it on a new and often smaller data sets. So this pre-trained model layers, which have already learned to extract general features from images, serves as a starting point, allowing the model to adapt quickly to the new task. Only the first few layers of the model are typically retained to specialize in the new task, which saves the time and the resources. Here you can see in the diagram. So what are the steps in the transfer learning? So you have the input image, and you have to detect whether this image is normal or the abnormal. We have the classic normal and the abnormal. We have the initial layer of the pre-trained model. We have so we have initial layer of the pre-trained model, we have replaced layer. So in together we are saying it is transferred pre-trained models. Okay, so what are the steps? Let us see one by one. So what we are doing, first we are choosing a pre-trained model. That means you are selecting a model that has been trained on a larger data set. Let's take an example, ImageNet. So the popular models include is ResNet, your VGGNet, your MobileNet. So first what you have to do, you have to choose a pre-trained model, and next step what you have to do is you have to freeze the layers. Okay, so in freezing the layers, that means you are freezing the initial layer of the model, which typically learns journal features such as your edges, textures, shapes. So these layers do not need to be retrained for the new task. Okay, so your third step is fine tuning of the model. So we are training mm, so the so we train only the last few layers of the model, because we have freezed the initial layers, and then we are fine tuning the model. How we are fine tuning the model? That means we are training only the last few layers of the model to specialize in a new task. Okay, so this involve adjusting the weight of these layers based on the new data set. So after fine tuning, what we are going to do, we are going to adjust the hyperparameters. Okay, that means you have to modify the hyperparameters, like suppose you have parameters learning rate, batch size is there. So based on the new task to ensure effective training. Okay, so what were the steps? First we have choose the pre-trained model. Second is we have to freeze the initial layer of the model. Next is fine tune the model, and next is adjust the hyperparameter. Okay, now we see that uh, what are the various steps. First is feature extraction. So pre-trained model serves as excellent feature extractor. So what you can do is that you can use the learned features from the intermediate layers of the network as the foundation of for other machine learning models or for various computer vision tasks. So these features are often more informatics and transferable than the handcrafted features. Then we have the improved performance. So these are the benefits of transfer learning, I can say, because since the model has already learned some useful features from the larger data set, so only the last layer needs to be retrained. Okay, so significantly it will reduce the overall training time. Okay, so this is one of the best benefit, I can say, of using the transfer learning model, that it will reduce your training time. And next is that it will improve the performance. How it is going to improve the performance? Because it will allow the model to generalize better, and especially when the target data set is small or it lacks diversity, the pre-trained model will bring in prior knowledge, which helps in faster convergence and often better accuracy. Okay, and or reduce overfitting. How? Because this pre-trained model have already undergone training on large data set, which often helps to prevent overfitting when you fine tune them on the specific task as they start with meaningful weight initialization. Okay, so transfer learning is basically I can say especially useful when there is limited data available for the new task. Okay, so by incorporating the features learned from the larger data set, the model can perform well even with a small amount of data as well. Okay, so let us have some glance about all the model. So as I already told you about the LeanNet, AlexNet, PGG, GoogleNet, ResNet, Inception, DenseNet, MobileNet, EfficientNet, Exception. So let us just start one by one, that what are all these models and how we can use it in our work in the research purpose. Okay, so VGG16 is basically your deep convolutional neural network. Here we can see, which is developed by Visual Geometry Group VGG at the University of Oxford, renowned for its excellence in image classification task. Basically, it consists of 16 layers with weights. Okay, why this is called as VGG16? Because it consists of 16 layer with weights, including the 13 convolutional layer and 3 fully connected layers, all using small 3 cross 3 convolutional filters, and we can say 2 cross 2 max pooling layers. Okay, so this VGG16 is straightforward. It has a straightforward design with uniform layers and ReLU activation. Okay, let me show you the diagram first. So here we can see that it consists of 16 layers with weights, and it is 3 cross 3 convolutional filters and 2 cross 2 max pooling layers. Okay, so we can say here that although it performs exceptionally well in a task like image classification, it has a large number of parameters, I can say, making it computationally expensive and slow to train. This VGG16 is used in transfer learning, where it is pre-trained layers on data sets like ImageNet, fine-tuned for specific tasks, allowing for more efficient training with smaller data set. Despite of this simplicity, VGG16 has been used in deep learning for applications like image classification, object detection, feature extraction, I can say. Okay, so what are the various steps? Let me tell you one by one. So first is input layer, then is convolutional layer, max pooling layer, fully connected softmax, and flattened layer. So this is similar to CNN what we have seen. So input layer, we can see here VGG16 accepts the input images of the consistent resolution, typically set at 224 into 224 pixels. So these input image conventionally consist of three color channels. What I told you before, the three channels RGB. Next we have the convolutional layer. So VGG16 has 13 convolutional layers and three fully connected layers. Therefore, it is 16, and therefore it is called VGG16. Okay. So these convolutional layers are responsible for the extraction of hierarchical features at various scales within the input image. Next, we have the max pooling layer. That means after each pair of consecutive convolutional layers, a max pooling layer is incorporated. Okay, after convolutional layer, we have seen in the CNN model that max pooling layer is incorporated. So these layers serves the purpose of downsampling. Okay, because we are doing the feature map operation, we are getting the convoluted matrix over here, we are downsampling, we are reducing the spatial dimensions, we are reducing the height and the width of the feature map while retaining the significant feature information. Okay, next is fully connected. Okay, so that we have seen in the CNN model that the fully connected layer, that means VGG16 incorporates these three fully connected layers. The initial two layers are equipped with 4096 neurons each, while the final layer contains 1000 neurons. So the ultimate layer aligns with the number of classes in the ImageNet dataset and undertake the task of high level feature abstraction and classification. Then we have the softmax layer. Okay, and then flattened layer. So what is the purpose of softmax layer? For assigning classes probabilities to the various categories within the classification problem. Next we have the flattened layer. This is that means we are converting into the one dimensional array, thus making them amenable for input into the fully connected layer. Okay, here is the structure of VGG16. We can see the convolutional operations, the max pooling operations, and the fully connected and the software we can see here. Okay, next we have the VGG19 architecture. So the question might come to your mind that what is the difference between VGG16 and VGG19. Basically it lies in the number of layers in the architecture. VGG16 has 16 layers with the weight, and VGG19 has 19 layer with the weight. Okay, so both architecture follow a similar design and structure with 13 convolutional layers, but the key distinct, I'll tell you one by one. First, we can say as number of layers. Okay, so VGC16, as I already told, that 16 layers, and 19 is 19 layers. In 16 we have 13 convolutional layers and three fully connected layers. But if I am talking about VGG19 will have 16 convolutional layers and three fully connected layers. That means both of them will have three fully connected layers, the remaining will be the convolutional layer. Okay, so if the after that we were having the first layer as the convolutional layer. So if I talk about convolutional layer for VGG16, I told that it has 13 convolutional layer with max pooling layer after every two convolutional layers. But in VGG19, what we have, it has 16 convolutional layers, okay, with additional convolutional layer compared to VGG16 placed before the fully connected layer. Here you can see the difference. Okay, so if I talk about the model size, you will ask that which is larger, which is smaller, is VGG16 smaller or VGG19? So we can say that VGG16 is slightly smaller in terms of the parameters, I can say, compared to the VGG19 due to fewer convolutional layers. Okay, and VGG19 will be slightly larger and little bit computationally expensive due to the extra convolutional layers resulting in higher number of parameters. Okay, and if I talk about the, if I want to compare the performance of VGG 16 and VGG 19, then both models generally perform similar task like image classification. Just the only difference is the additional layer in VGG 19 might capture slightly more complex features than VGG 16. Okay, so you can go for VGG 19 because we know that it has more convolutional layers. Okay, so if I say, if I talk about that, which trains faster. Okay, so VGG 16 will uh, train faster and uh, require less resources, okay, due to its fewer layers. But VGG 19 slightly slower in training and require more computational demand due to increased number of layers. Okay, so every model has some pros and cons, so it depends. So it depends what type of situation, or the what type of you want, whether you want faster training, whether you want like uh, because parameters will be more in 19, parameters will be less in 16. So you have to see that performance training, you have to see everything. Okay, so as I have already told you the difference between both of them, VGG 16 and VGG 19, so no need to tell all these things again. So let us see ResNet. Okay, ResNet is also another deep learning architecture. Okay, that was introduced as deep residual learning for image recognition by the team of researchers at Microsoft Research, represent a pioneering development in the realm of deep convolutional neural network. Okay, so we see that the core idea of this residual block is to learn the difference between the input and the output, which helps, actually, which helps to optimize this networks without degradation in performance. Okay, so this ResNet is available in various versions. Like in VGG we have VGG 16, VGG 19. In ResNet also we have ResNet 18, ResNet 50, ResNet 152, with deeper versions using this bottleneck architectures to reduce computational cost. Okay, so the ResNet ability is to train the deeper network efficiently, even with hundreds or thousands of layers, I can say, and has led to its widespread adoption in tasks like object detection, image segmentation, transfer learning, where pre-trained models are fine-tuned for a specific task. Okay, so let us see the structure of ResNet. So we have the input layer, initial convolutional layer, max pooling layer, we have the residual block, we have the bottleneck architecture. Okay, stacking of block, global average pooling. See here we have the global average pooling. Okay, that means it computes the average across the spatial dimension of the feature map. Okay, yielding one dimensional vectors that serve directly for classification. So we, this is the architecture of ResNet where we can see here. So this is one of the most successful architecture for image classification and other computer vision tasks. Okay, and the core idea of this residual block is to learn the difference between the input and the output only, so which helps in to optimize the deep networks without the degradation in the performance. Okay, so this is the diagram for the ResNet we can see here. Okay, next we have the Google Net, which is the another architecture. Google Net, we call it as it is also known as Inception V1. Okay, Google Net architecture, if you want to say, it is also called as Inception V1. Basically, this is a deep convolutional network architecture which was developed by Google. Okay, so its key innovation is the Inception module. So what is this Inception modules? That means it combines multiple convolutional operations, 1 cross 1 comma 3 cross 3 comma 5 cross 5, so multiple convolutional operations it will combine, and max pooling in parallel. That means it is going to perform the operations in parallel, allowing the network to capture the features at different scales while reducing the computational cost. So this Google Net will basically use the global average pooling instead of fully connected layer. Significantly, it will lower the number of parameters and improve the efficiency. Okay, so if I say additionally, it will also incorporate the auxiliary classifiers as well. So it helps with gradient flow and regularization. So despite having only 22 layers, GoogleNet will achieve high performance with fewer parameters only compared to the other architectures which we have seen in VGGNet. So making it ideal for the image classification, object detections, and transfer learning applications. Its efficiency and scalability have influenced subsequent models such as Inception V2, Inception V3. There are several variants we can say in Inception also, as we had in the ResNet, ResNet 80, 18, 50, 152. As per your requirements, you can choose the model. Okay, and if you are very much confused picking up the model, you can just go through the Google Scholar and you can see which models have been referred recently. Okay, now you can see here how these operations are performing. Nothing will be visible, but the only intention is to show you that how these operations are performing in parallel. Okay, now let us see this AlexNet. The model, I'll only cover a few pre-trained models because it is highly impossible for me to cover all the pre-trained models. Okay, now see, AlexNet is basically your another deep convolutional neural network architecture, and this was developed by Alex, so that's why its name is AlexNet, and it consists of 8 layers. Okay, so in 8 layers we'll be having 5 convolutional and 3 fully connected layers for this AlexNet, and here we'll be using the activation function ReLU will be used, which is rectified linear unit for faster training, and we have the GPU parallelization also for efficient computation, data augmentation, dropout for improved generalization, and reduced overfitting. So by achieving a significant performance, uh, so we can achieve significant performance in large scale by performing the task. So AlexNet demonstrate the power of deep learning by setting the stage, I can say, for the future advancement in computer vision. So AlexNet, we see here the several layer. First is the input layers, convolutional layer, max pooling layers, uh, local resource normalization, response normalization, dropout, fully connected layers, softmax, flattened augmentation, and this is the layer we can see how they are fully connected. The input convolutional layers, fully connected layers. Okay, now let us just summarize that as we have talked that LeNet, LXNet, VGG, GoogleNet exception. Okay, so where I was like VGG already discussed, GoogleNet, ResNet already. So inception, I can say that GoogleNet architectures are also called as inceptions models. So which build with Google, which is built upon the GoogleNet design. Okay, we also have dense net, which uses dense connectivity between layers for better gradient flow. We also have mobile net. In the previous session, I saw one resource person was teaching about the mobile net architecture for detecting the plant disease classification, and this is basically designed for your mobile and the embedded devices with depth-wise separable convolution to reduce the computational complexity. Okay, so basically mobile net is designed for your mobile and the embedded devices. Okay, so as per your requirements, you have to pick the model and you have to use it, and you have to see how much accuracy you are getting. And if I talk about apart from mobile net, we also have other models like efficient net, so which offers a scalable approach to balancing depth, width, and resolution, resulting in efficient model. That means you are trying to balance the depth, width, and resolution with fewer parameters only. So we have efficient net for that purpose. Okay, next we have exception, which is then further improvement, I can say, over the inception architecture. which uses the depth-wise separable convolution to improve the performance and efficiency. The pre-trained CNNs are basically are particularly useful for transfer learning, where a model trained on one task is adapted for a different task, enabling the faster training and improved performance, especially when available data set is small or lack diversity. So these pre-trained models available in popular frameworks like your TensorFlow, PyTorch make it easy to apply state of the art models to various real world problems. Okay, so if you try to compare the accuracy, like which year it has come, what are the salient features, what are the top accuracies, what are the parameters, what is FLOP. So in the comparison table, all the other details I think you are able to understand. Only the thing is FLOP. What is this FLOP? This is FLOP basically stand for is floating point operation, which refers to the number of floating point calculations, that how much calculations it is doing, like operations like your addition, subtraction, multiplication, division, that a computer or a processor performs in a given task. You can see 1.5 billion for LXNet, 19.6 billion for VGGNet, 2 billion for Inception, 11 billion for ResNet 152. Okay, so we can see here that it is used this FLOP is used as a metric to measure the computational performance or the complexity of the algorithm, particularly in the fields of deep learning, scientific computing, or your machine learning. Okay, so this FLOP basically is used to quantify the computational workload. Okay, and this is often expressed in terms of operations per second, and this is used to compare the computational power of different hardwares such as your CPU, GPU, or specialized accelerators like your TPU, I can say. In deep learning, this FLP count can indicate the complexity of the model. Okay, so by seeing the FLOP only, you can visualize the complexity, that how much complex this model can be. Okay, and the computational resources needed to train or infer for the model. Okay, for example, you can see a deep learning model may require billions of floating point operations, okay, for training on large data set, and this is often used to assess the model efficiency in terms of speed and resource consumption, right? Now let us see the coding for the pre-trained models, then we'll see the comparison. Just three more slides for the comparison. First we will see the coding. Okay, now let us take one application, like suppose you are using an auto encoder for Hmm. Let's suppose you are using convolutional autoencoder. I have taken one application where I am regenerating the image. Okay, whatever is the output, I am getting as the input. I am trying to reconstruct the image. Okay, reconstruction is happening. Where auto encoders can be used, it can be used in removing the watermark, removing the noise, removing the reconstruction, image enhancement, or so I'm using convolutional auto encoder. Let us see how we can do. That means we are using CNN model over here, we are using autoencoder and the convolutional operation over here. Okay, so let us see how we are going to do. First we are going to import the libraries like Keras, NumPy, Matplot. I will definitely share the PPT as well as I will share you the code also, so don't worry about that. And if this lecture is getting recorded, so you might get the uh, this video also. Okay, so don't worry about that, and if you have any problem you can mail me also. I will ping in the chat box. Okay, don't worry. Okay, and if you have any query in future regarding the research, that how to carry out the research, how it is you have to carry, how you have to study, like any problem you have, you can ask me directly in my mail. Okay, so where I was, so I have to import the necessary libraries like import NumPy, Keras, Matplot for visualization. I'm using MNIST dataset. MNIST dataset is basically having the digits 0 to 9. So my data will be having the image, and those images will be the images of the digits from 0 to 9, and that only you are trying to reconstruct it using the help of autoencoder. Autoencoder is just the application I have used. Okay, so and now I'm going to import the model input, whatever is required to create my model, like layer, dense, dropout, activation, flatten, reshape. We are importing the regularizer also, as I have discussed that in order to avoid the overfitting we have to use the regularizer also, L1 or L2. Okay, now we are going to import this convolutional 2D, max pooling, upscaling, zero padding. Okay, now our data, MNIST data, is basically your non-labeled data set, unlabeled data set. So we will be having X train and X set, because Y train will consist of the labels, and we don't have the labels right now over here, so there will be nothing over here. Okay, we just have the images, we don't have the labels. So we have loaded the data. Our data is 28 cross 28 cross 1. Okay, after that we are going to reshape our data. Okay, reshape our data. Okay, after that, after reshaping, you can see how many images I have 60,000 images. What is the size of the image? 28 cross 28 cross 1. One is the RGB. So in the autoencoder, what is the structure? What you have to do is, first you have to create the encoder part, then you have to create the decoder part, and in between the encoder and decoder we have also one latent dimension. Okay, one latent dimension is there through which this encoder and decoder will be connected. So this inside this encoder we are having the convolutional operation, we are having this max pooling operation. See, we are having three layers, three convolutional layer. This is the number of neurons, this is the kernel size, right? This is the number of neurons, this is the kernel size, this is the activation function I am using, this is the padding, and each layer is connected to the previous layer. So this X is connected to the previous layer, this pool 1, that means it is connected to the previous layer. Here you can see. Okay, so encoder will be in the neurons will be decreased, and decoder is just the reverse of the structure whatever you are making for the encoder. Decoder is just the reverse for it. That means 8 will come here, 8 will come here, 16 will come here. Okay, so we have created our encoder and decoder structure right now over here, and then what we are going to do is we are going to see our model. We are seeing our model, that how does our model look like. Okay, we have seen the summary over here, that we have several convolutional max pooling layers in our encoder and decoder architecture. Now we are going to run our entire data set, and we will see how much accuracy we are getting. We have run for 50 epochs, and the batch size we have kept as 1000, because we have 60,000 images. Okay, we have how many images? I think 60,000 images, and so we have kept it the batch size as 1000, right? So while training, we saw that we have got the loss 0.12. Okay, validation loss is 0.12. Okay, so let us visualize our data, that how our image is reconstructed. Okay, now let's see. 7 is reconstructed as correct, 2 is reconstructed as 2, 1 is reconstructed as 1, 0 also correct. See, there is again a flaw. This 4 is not reconstructed as 4, it is reconstructed as 9. That means we need to fine tune the model, or we need to adapt some other strategy. We have to tune our hyperparameters. Okay, 1 is corrected, 4 is little bit correct, not exact, but yeah, correct. 9 is also correct, 5 is also correct, 9. So there is only one wrong notation over here. That means our neural network is not able to identify 4 and 9. See here, 4 and 9 is little bit confused. So we need to fine tune our model. So let us see the accuracy. So let us visualize it. See, our training and validation lines are very near. That means our loss is very very less. Okay, So this is one of the example I have shown you, that how we can use convolutional operation in the auto encoder, and also I will show you some pre-trained models as well. Okay, now let us use cipher data set to classify the objects. Okay, as usual, you have to import all the necessary libraries. Next step is you have to load the data. Next step is you have to normalize the pixel values. Next step is you have to convert the class vector to binary class matrix, right? And then enhance image generator for data augmentation, that if the data is less or if the data is overfitting, please do the augmentation. Here we are doing rotation, shift operation, width, height, shear range, zoom range, horizontal, flip, no flip mode. Okay, these type of augmentation step we are doing over here. Okay, next step is, that is loading and adapting pre-trained model, where we are loading the pre-trained model, what is VGG16. Okay, and our input is 32 cross 32 into 3. Okay, so what we are going to do is we are unfreezing the last few layers of the base, because we have to modify our last few layers. Okay, now we have to add our custom top layers for the cipher 10 classification with batch normalization. So this is the top layers we have added over here, and then we have compiled the model with the SGD optimizer. Actually there are several other types of optimizer. We have used here SGD. You can use Adam optimizer, you can use RMS prop. Okay, based on the accuracy and the loss whatever you are getting, you can change the type of the optimizer over here. Next we have seen this training the model. Now after compiling, we are training it and running the data for the 20 epochs. Okay, so we see that how much accuracy, 0.85, and the loss is 0.43. Okay, now we see that let us visualize our model accuracy, how much we are getting it. So we can see that we have got 85% accuracy and 0.43% loss. Okay, so where this blue line you can see the training accuracy, and the orange is the validation accuracy. Likewise for this loss also. Okay, so we have seen now how we can classify. Okay, here see, we have to unfreeze the last layer whenever you are using some pre-trained models, like suppose AlexNet, EfficientNet, MobileNet, or VGG16, ResNet. Try to do these steps. Okay, these steps you have to perform in your work. Okay, anyway I will share you the code, so no problem. So now let us see now. Now let us see now AlexNet versus ResNet 152. Okay, so you, whenever you are doing some research, after doing the implementation, you have to compare your work with the state of the art method. Okay, you always have to compare your work with the other existing work that has already been done in the latest years. Okay, if you're not able to do the state of the art comparison, then there is a possibility of rejection of your paper. Okay, and many times it will get rejected, or it will come for major revision or minor revision. After major minor revision also, sometimes it happens that your paper might get rejected. So always keep your paper base very strong. You should have a good literature in your work. You should have good result. Not only good result, you should have the good comparison as well. Okay, or like suppose you can do comparison, you can create your own model, you can optimize the model. So this is how you are going to bring the novelty in your work. Okay, either you are reducing the line of code in the work. Okay, you are trying to optimize the algorithm. These things will create or bring novelty in your work. Whatever research work you are doing, okay, you should always bring novelty in your work. How you can bring? If you are trying to do some applications which is related to image processing, deep learning, machine learning, always focus that you have to bring some novelty. Okay, so let us compare relatively. As in the previous slide I have showed you that I have done this, is there is a comparison like between the model, which year it has come, what are the salient features, what are the top 5 accuracy parameters, FLOPs. So likewise you also have to do the comparison. Maybe you have used one type of data set, like suppose if I use your model with some other type of data set, it might not work properly, or it might work very good. Okay, so all these factors you have to see, right? So if I compare this AlexNet and ResNet 152, so these both have similar number of parameters, but 10% difference in there in the top 5 accuracy only. So ResNet 152 is computationally more demanding, I can say, and requires approximately 10 times more computations than AlexNet. Okay, so the higher computational complexity of ResNet 152 translate to longer training time and increase energy consumption. So what I can tell you with this, that ResNet 152 has a superior top 5 accuracy, uh, that may justify is increased computational complexity for specific application where high accuracy is paramount, and however for applications where slight lower accuracy is acceptable, AlexNet may be preferable. Okay, so it is like if I want to, if I give you some work to do and if I say you that which one do you prefer, so you can go for the ResNet 152. And but it depends again that what type of data you have, what type of work you are carrying out. Okay, it depends on that. Now if we try to see the comparison between VGG net and ResNet 152. So VGG net not only has more parameters and FLOPs compared to ResNet, but also demonstrate reduced accuracy as well. Okay, so training VGG with its higher complexity results in lower training time, requiring sustainable computational resources. So VGG would be good, like combined with lower accuracy compared to the ResNet 152. Okay, now if we talk about AlexNet versus Inception is basically your Google Net model. So training and AlexNet takes about the same time as training the Inception, but the memory requirements are 10 times lesser, I can say. So despite lower memory requirement, AlexNet demonstrates an improved accuracy of about 9% compared to Inception. So the reduced memory requirement of AlexNet makes it more efficient choice for scenarios with limited hardware resources. Its improved accuracy despite similar training times enhances its appeal in many practical applications. Okay, so if anybody is having any doubt, they can ask me right now over here. I have explained so many beautiful models, I can say beautiful pre-trained models with real-time examples. Okay, so if anybody is having any doubt, can ask me. Participants, if anybody is having any doubt, please, yes, YOLO can also be used. Somebody has texted, yes, YOLO can also be used. I am just typing my mail ID so that you can ping me later also if you have any doubt regarding research.
Ma'am, can I ask doubt now?
Yes, sir, yes, sir, sure.
Yeah, ma'am. Actually, you talked about pre-trained network, right? Pre-trained model.
Yes, sir.
Yeah, ma'am. Actually, but can you brief how we can apply this transfer learning in medical images? Is there
Oh,
any yeah, ma'am. Because I went through a lot of literature.
hmm,
This pre-trained model things has been applied in
hmm,
general images like cars, like
hmm,
auto driving, like that. So when we
hmm,
move on to medical images, where is the source? Whether is there any link is available
hmm, hmm, hmm,
which automatically pre-trained
hmm, hmm.
images has been implemented? So
Uh,
can you,
Sir, yes, sir. Your question is very good actually, and bringing it to the current scenario. And I think many researchers are
uh,
working with the medical imaging data set using this pre-trained model only. Let's take an example of the COVID-19 only, because when COVID cases were exponentially increasing, so we were having exponential increase in the growth of the data of whether it is CSV data or it is medical image data. So people were trying to use those medical data, were using those radiography images or
oh,
pathology related images were there with them, so they were trying to classify using the pre-trained models. Okay, so
okay,
like suppose you have the chest x-ray images of a person and you have to classify whether the person is having COVID or not, or you can take an example whether the person is having the cancerous cell or not, or tumor is there or not. Okay, so first is that you should have the data. You can download it from any source like Kaggle, you can download. Okay, or you can download from UCI repositories there, or you can even consult to the doctors and get the data from there, but it is very difficult to, because data are very sensitive. Okay, so what you have to do is first is that you have to take the data. If the data is less, you have to augment the data. Okay, and after that you
okay,
have to choose the pre-trained model. I have already described so many pre-trained model like VGG 16, 19, ResNet, EfficientNet, MobileNet, AlexNet, InceptionNet. So as per your requirements, you have to pick the pre-trained models, and you have to do the classification. Okay, so the task is classification only, but the thing is you can tune your model, you can fine tune it, optimize your model. How you can bring the novelty? Now the task is that, okay, either you create your own novel structure, either you optimize the model. Okay, either you optimize the algorithm, try to create your own algorithm, or reduce the lines of code in your work. Okay, so this, that is how you have to bring the novelty, and you also you have to compare your work with the existing art of techniques.
okay, ma'am. In this case, ma'am, you have talked about we can take from some repository, we can take images, or as I am working in one private institution, so we have less data for real-time based TB cases. So in that cases, we got only samples around 100 images. We convert through that augmentation. So
Mhm.
we did some efficient ResNet and VGG comparative study.
Mhm.
So for next level of model, we are in lacking of images. So with this comparative, we can divide this part as two paper and we can submit it for research. Is it possible, ma'am?
Actually sir, your thing is your data is very less. The thing is, after augmentation also I think that your data will be less. Is it possible for you to create synthetic data? I can suggest you one website. In my mind it is going Gretel. There is one website, Gretel. Okay, so where you can create your synthetic data. I have created for CSV, but I don't know about images whether it will be working or not. But there are some websites which will generate synthetic images.
Okay, what is synthetic images mean? It's new for me. I don't know exactly.
Synthetic images is that you are creating your own data. Okay, you are synthesizing the data. That means you are not doing augmentation, you are creating your data.
Okay,
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 so you can use the websites that can synthesize your data. As if I know that for creating synthesizing the CSV data, there is a website called Gretel, Gretel. Okay.
okay, ma'am, okay.
Hmm.
When we move on to segmentation, what type of websites or any tool is available? Free tool, ma'am. For example, for example, I am taking X-ray images. If I want to extract the lung part, that is segment the lung part. What type of tool available, ma'am? Any idea in segmentation freely? Because
Uh,
nowadays,
s-
yeah.
Segmentation, yes sir, there are tools. I think
We have tried. They are giving some limited images, and then they are for with a trial period, and they asking to buy license like that.
yes sir, because of the marketing strategy they people are doing.
Yeah,
Yes sir.
yeah.
Yes, there are available several tools, but only the constraint is that only that we have to pay for that. That is only the
Okay,
problem, sir.
Okay. Other than any other tool which you know, ma'am, so any idea on that?
Mm, I think it's not coming in my mind right now, sir.
Okay,
So,
fine, ma'am.
mm,
Okay, the final last question, ma'am. As I talked about that comparative study, you talked about state of art, right?
mm-hmm,
So I told I have taken around four pre-trained model like efficient freshness. Can I
mm-hmm.
divide that as a two model output and state of art as a one paper, and another two as state of art as another paper, and I can submit
Yeah,
whether
you can
this
submit. You can submit. The objective is same, sir.
yeah objective is same only, ma'am, because objective is automated analysis we planned.
Okay, you can do, sir. You can.
Okay, ma'am. If any doubt, I can